So in this lecture, we are talking about the non-linear separable data. Till now, we are assumed that our data is linearly separable or it is almost linearly separable. But in this lecture, we are talking about if our data is non-linearly separable, then how using logistic regressions we are separate this data. Okay, so let's start. So suppose, first let's consider a non-linear data. I am using the this site is our f1 features and this site is our f2 features. It is a 2D system. Okay, and our one data set is like this. And another data set. Let blue color is our negative and just pink type of color, it is our positive data sets. Just let this is simple. You can understand these two type of data set is not linearly possible. It is not linearly possible to separate this data. This is a non-linear kind of data. Okay, these are two data sets. So now the big question arises is that can we using logistic regression to separate these classes of data? Okay, just write down. Can we use logistic regressions to separate these classes or simply these data, as you like? Okay. Now, if we want to draw a plane to separate this data, suppose we want to draw a plane like this or this, it is impossible to separate these two classes. Okay, the best separator here is this. If we use this non-linear separator, that is two circle. Okay, if you use these two kind of circles, then it is perfectly classified. But here, drawing a plane, it is impossible to separate. Okay, so just simply drawing a plane in the space that is space of what? In the space of f1 and f2 cannot separate. Cannot separate positive and negative points. Okay, simple. You can see here, simple using a plane, it is not possible. Now, what I have to do here? Now, here we are using the concept of features engineering. Now here we are using the concept of features engineering. Now let's take what is features engineering. Now for let's just redraw this picture again. Okay, now again I am drawing the axis. Okay, so we have 2 points, one is blue, one is pink. This one is blue point and another one is another class. So this is the positive class, blue one is, suppose let's say it is the negative class. Okay, just I think this is okay. Okay, these are two classes we have, and these features is f1 features this side and this side is the f2 features. Okay, and in one language it is a space of f1 and f2, and let's its one point, call its one point as xi, whose data point is like this, xi1, xi2. Okay, now here we are using features transformation. Just simple here using features transformation. Or another language it is called feature engineering, feature transformations, or in feature engineering as we call. Okay, so we transform these two features in such a way that in the space of, suppose in this space, this is the space of f1 dash and this side we call the f2 dash. Here in the space of f1 and f2, these data sets are nonlinear. But using features transformation, we are transform this feature in such a way that these data sets are linearly separable in the space of f1 dash and f2 dash. This is the space of f1 dash and f2 dash. Okay, now I want to transform this. Now this is the creativity. Now this transformation using your just practice and how you are creative about the mathematics of the features and how you to visualize the data and how to using your creativity, how to use your knowledge, how to using the mathematics. This is the main thing. This is totally depends on your practice and your experience of the data. This is okay. So here just say here we are using this type of features engineering. Suppose let our f1 dash, just bear with me, just see it, and then you can see how it transform the nonlinear data to a linear data. Just see it. Okay, f1 dash is equals to f1 square and f2 dash is equals to f2 square. Okay, now we are using here f1 means what, f1 square, and f2 dash means what, f2 dash means f2 square. If we transform these data, suppose let's consider only the blue data points. Okay, now after that we are going to the pink data point. Okay, this point, first consider the blue data point. If we just taking the blue data point, here we are converting f1 square and f2 square, means all the data sets f1 space and f2 space are converted in positive, only positive. If f1 is negative, if this side f1 is negative and this side f1 is positive, this side f1 is positive and this side f1 is negative and f2 is positive, it means this f1 square and f2 square means what, we are transforming all the data sets in only positive direction. Okay, so these blue data sets are now transforming into positive directions only. Every data points are now converted into positive. Okay, now consider similarly you can see the pink data point. Now pink data point, if we using these transformations, so every data point it is transformed into as well as positive directions only, f1 as well as f2. If we transfer this data, then it will be plot like this. Okay, now in the space of f1 dash and f2 dash, you can see that these two spaces are linearly separable now. Now these are almost linearly separable. You can just see it. These are almost linearly separable. So since in the space of f1 and f2 it is linearly separable by using simple features transformation, then here you can easily use logistic regressions. It is linearly separable. Now you can ask a question that, sir, how you can choose these transformations? Why we are deciding this transformation are suitable only for this space? So I'm just previously speaking that this is totally depending on your experiences and as well as your expertise of this, as well as your experience in data science. Okay, this is totally depend on your practice, how much you practice, how much you play with data. This is totally depends on it. Okay, I think how features engineering are applicable on data science, you are now easily learning. Now let's another problem. Suppose if we just summarize this concept, how we can just we are a data point xq, this is xq1 and xq2. Okay, by using our features transformation or feature engineering, we are converted these data points xq dash, that is xq1 dash and xq2 dash. Okay, so these points are in what? This point is lie in f1 and f2 space, and this point is lie in f1 dash and f2 dash space. Okay, now after using the logistic regression point, because we have seen that in the space of f1 dash and f2 dash it is linearly separable. Now here linearly separable or almost linearly separable. Now here we can easily use logistic model. Now here we can easily use logistic model to find a plane there called as pi dash to find our output, that is called y cube. Okay, means here it is non-linearly separable. Here we are using features transformations, or it is called feature engineering. In this space it is linearly separable. Okay, now here easily we can use the logistic regression. Okay, now the main question is, how did you know which transformation apply? Just previously I am also telling that it is totally depend on your experience and how you play with data, what is your creativity, how to tackle a problem you have. So it is totally depend on you, depend on your creativity, okay, and your experiences. So now let's, why it is happen. If you want to just put down a question, sir, why it is happen, how it is mathematically analyze this concept. So easily, if you see this data, this is just see this data. This is a type of circle equations, as well as this is a type of circle equations. Okay, there are the two type of circle equations. So we know, everyone know that the cycle equations of a circle can be written as in this form: f1 square plus f2 square is equals to r. Okay, f1 square plus f2 square is equals to r. So if you see the f1 square, just write down in below. We are writing f1 square plus f2 square is equals to r. If we just call this one and this one, this in f1 and f2, simple, just think about it. In f1 and f2, in f1 and f2, these are not linearly separable. Non okay, or if we call this one f1 total, that is f1 square, f1 square we are called f1 dash, and f2 square we are calling f2 dash. If we call this, then the equations is converted to what? Now the equations is converted to f1 dash plus f2 dash is equals to what? R. And this you can easily talking that in f1 dash or f1 square, otherwise f2 dash or f2 square, it is linearly separable, because this is a linear equations, but here it is not a linear equations. So just this kind of creativity you have to use. This is linearly separable. Now if you ask a questions, sir, what is the most important aspects in the world of machine learning or artificial intelligence, then I am summarized you these three things. Just simple, right now. The most important, if you ask me, but what is this, sir, what is the most important aspect in world of machine learning? Or AI? Then I can say you the first one. I am choosing the first one. There are many most important things, but about them I am choosing the most one is feature engineering. Okay. Now second one, if I choose, then I am choosing here the bias variant trade-off. And if I choose the third one, then it will be the data analysis, how you analyze the data. So data analysis and how you visualize it, how you can visualize the data, visualization. Okay, I am choosing this thing. So in my concept or in my knowledge, the features engineering is the most important thing in the except of machine learning or artificial intelligence. Then bias variance trade-off, then data analysis or data. These three things I prefer the most. Okay, this thing is totally depend on your creativity or these things are totally depend on your skill, creativity, experience. This thing features will totally depend on your. Okay. So the why the deep learning is most important in the model machine learning. Why? Because deep learning, in the concept of deep learning, it has the automated features of features engineering. So deep learning is so popular because of it has the feature automatic, it has the automatic rule to features, that feature engineering, to apply the features engineering. When we learn this deep learning, then you can easily see it. Now let's take another example. Okay, let's this size F1 direction, this is the F2 direction. Let's take one kind of data set is here, another kind of data set is here. Okay, now let's take one kind of data set is over here, and another kind of data set is here. Okay, now using features engineering, simple, you can see that these two data are not possible to linearly separable. Because why? Because this portion is this classifier and these are these type of classifier here. It is not possible through a single line you can separate this data. Okay, So but just pause this video and think about it, how the features engineering are applicable here to the separate it is linearly. Okay, so simple, it is not linearly separable. Just pause this video and think about it. So let's start. How we can separate this data using feature transformation or feature engineering. How we separate this data. So let's think about it. Here you can see our see our F1 blue data first. Here in the blue data, this side F1 is positive and F2 is also positive. But this side, if we transform this data in such a way that our blue data is in the positive directions of the F2 and the gray data is the negative directions of F2. If we just transform these two things, okay, then I think F2 axis will be easily separate this data. So you can just think about it. Just I am saying that if I am separate those two data in such a way that if I am simply convert this in these directions and simple this thing in this direction, then our F2 axis easily be separated. These two data easily separated. So how it is we have separated this data? So to separate this data, you can see that in this direction what? In these directions our F1 is what? F1 is negative and F2 is what? F2 as well as is negative. Okay, but I want to transform this side. Means in this side our F1 is not matter, F1 negative as well, okay, it is okay, but our F2 will be positive. How we can transfer this data as F2 positive? So to transfer it, if we have applied F1 dash in such a way that F1 into F2, we are multiplying this, and F2 dash just simply F2. Okay, here F2 is what? Here F2 is positive. Here F2 in this data F2 is what? In this data F2 is, here F2 is positive this side and this side F2 is negative. Okay, just write down this. Okay, sorry, मैं just in another. Okay, so first let this side. Our F1 is positive and F2 is also positive. Positive plus positive means what? F1 will be positive and F2 as well. So this data will not be changed. So this data as well, we have write this data as well. It has no problem. It has no problem. This portion is no problem. Now let's come to this portion. Here F1, just write down it. Here F1 and F2 both are positive. Here F1 is what? This side our F1 is negative and F2 is also negative. If we multiply these two things, then F1 is what? f1 is positive. Is if we multiply these two things here, then f1 is what? F1 dash, sorry, f1 dash means f1 into f2. f1 and f2 means positive. f1 is positive this side, and f2 is what? f2 as well. f2 means negative. f2 this side will be negative, and f1 this side positive. f1 dash. So our data set will be this one. Oh, sorry. Just a minute. Just I'm using here the blue ink. Okay, just write down here f1 dash and f2 dash both are positive. Here what? Here our f1 dash is positive, and our f2 dash is negative. f1 is positive means f1 into f2, multiply this positive this direction. Okay, now come to this concept. Here what? Just write down here. Here f1 is what and f2 is what? Here in these directions our f1 is negative and f2 is positive. So if we write down this data means f1 dash, so what will be the f1 dash? f1 is multiply these two means negative, and f2 is positive, f2 will okay. So this data will be appear here, it is no problem. Okay. Now come to this data. Okay, now let's come to this data. So if you see this data, here f1 first f1 is what? Here in this direction f1 is positive and f2 is what? f2 is negative. So if you just transfer this data, then f1 dash will be what? f1 dash is multiplication 2 means f1 is negative. f1 dash is negative and f2 dash is what? As well as negative. So this data now is transformed to this side. Okay, now can you easily separate this data to a plane. Now you can easily separate this data using this line. Sorry. Now you can easily separate this data in this plane using this plane pi. This is linearly separable, but here it is not possible to separate the linearly. But in the space of f1 dash and f2 dash, it is easily linearly separable by using these transformations. Okay, if it is linearly separable, then you can easily apply here logistic regressions. So in the space of f1 dash and f2 dash, it is linearly separable. You can easily separate this data. So another language, this kind of data is called the XOR data. Why it is called XOR data? because if we call one data set is 0 and another class of data set is 1, then this kind of data it is 0 0 1 1 0 1. So this kind of data, XOR transformation. So because of this, it is a XOR. This kind of data set is called the XOR data set. Okay, so using this concept, features engineering concept, we can easily separate this data linearly. Okay, I think all are about clear of this context. Now let's take another example. Example number 3. Let's take another example. Suppose let's take this kind of data set. This is the F1. This is the F2 data set. Suppose we have two kind of, one is white point, one is red. Suppose this kind of data we have. Now the question is, you can easily see it is not possible to use a single line to separate this data. It is totally impossible to separate in using a single line. So it is simply non-linear separable data. Okay, it is clear. Now the concept of how using the features engineering we can transform this data set into a linear set of data sets. So just pause this video and think about yourself how it is possible. Just think it, just use your creativity. Okay, just think. Okay, let's see how it is possible. So just you can see, you are, I think all of you are learn about the sine functions. So sine function is what kind of sine is what? Sine is, I am not using the sine positive or negative, I am using trigonometric sine function here. Sine function is what kind of sine functions? If I use the sine functions, sine function is like this. This one is positive, then negative, then positive, then negative. This kind of function is called the sine function. Means what? And if I divide this region, this one, this one, this one, this one, so then you can easily see that in this region, here divide this person 4 region. So in this region it is what? It is positive. In this region it is negative. It is positive here and it is negative here in this region. Okay, this is the sine function. Here it is the x. Okay, now we have to use the features engineering to separate this data linearly. How we are used it? Just we are using features engineering, or it is called feature transformation. Which kind of features transformation using? Here we are using the sine functions here. Sine type of concept means positive, in this person negative, this is positive, this is negative. This type of concept here we are using here to separate this data. So simply from, if we use our features is like that, f1 dash is equals to sine of f1 and f2 dash is as well then you can easily see. Now let's see how it is separable. Just a minute, sorry. Okay. This side is f1 dash, this side is our f2 dash. Okay. Now f1 dash, this portion, this side, here it is what? f1 dash means sine of f1, sine if f1, this portion, sine of f1, this portion means what? This portion mean our positive, f1 is positive, and f2 as well. So f2, if f2 as well, now I just now I am using the white portion data, this portion data, just see it, f2 as well, f2 as well, f2 as well means this spread of this data, this direction is fixed. And f1 dash means what? F sine of f1, sine of f1 means this portion is positive, you can see here. If this portion is positive, so this white portion is drawable here. Now let's see the red portion of our data, this portion of our data, let's see. So in this portion, left portion, what will be the sine value? Sine value is negative, means f1 dash is what? F1 dash is negative, and f2 as well. So this portion of the data will be plotted here, because f1 dash is negative in this region. Okay. Now let's see the second strip, white portion data, white portion, this portion. Now let's see this portion. So in this portion, sine is what? Sine of f1 means again it is positive, and f2 as well. So f2 as well, as we draw f2 as well, and f1 is again positive, so this data again is drawable here. Okay. Now let's see the second strip of the red data, this portion data. Again it is negative here, this side, this portion means this side negative portion, and f1 dash will be negative, and f2 as well. So this portion, this kind of data again will be this region. Okay. Now you can see it is easily separable here. In this region, this is easily separable using linearly separable file. So by using these features transformations in the space of f1 dash and f2 dash, this data set are easily linearly separable. It is linearly separable, but in the space of f1 and f2 it is not linearly separable. Okay, in the space of f1 and f2 it is not linearly separable, but using simple sign transformations it is separable. I think using these three examples, now you are clear about the features engineering. Now it is totally depend on your creativity and your practice and your visualizations of the data. How you can visualize, how you can analyze, how your skill, mathematical skill, it is totally depend on you. Okay, there are various type of features, real valued features transformations. Just write down one by one. So typical transformations for real valued features. Okay, what kind of typical? So first one is the polynomial feature. It's called polynomial features. So polynomial features is what kind of features? It is like f1 into f2, f1 square, f2 square, f2 cube, f1 cube, f1 square, f2. Such kind of features transformation is called the polynomial features, polynomial type of features. Now second type of features, mathematical type of feature. Mathematical features is what? Just previously I've seen sine of f1, exponential of f2, log of f1 into f2. This kind of features is called the mathematical features transformation. Okay, now let's another type of, sorry, this one is mathematical, but you can use trigonometrical as well. You can see it is the already trigonometrical. This kind of exponential, logarithms, etc. These kind of features are called the mathematical. Now the trigonometrical features. Trigonometric features is what? For sine of f1, cos of f1, sine f1 into cos f2, sine f1 square, okay, this type of features are called the trigonometrical features. Now fourth kind of is called the unkind Boolean features transformation. So what is called or, and, or. This kind of feature transformation is called the Boolean features transformation. Mainly these kind of typical features transformations are publicly used in daily life. But there are various kind of features transformation. Just it is using on your problem base. It is depend on a totally problem. What kind of problem you are used. Now they have another kind of features transformations. You can if you see the Amazon food review data set is totally available freely, totally available on Kaggle. Kaggle is a useful machine learning competition websites. If you're interested to analyze or visualize the data more perfectly, or if you just want to interest to participate in data science competitions, then I am requesting you please just sign up your account. It is totally free in Kaggle. Then they have various kind of data science competitions. Okay, if you there you can easily see freely Amazon review data sets. If you see the Amazon review dataset, then there you have to transform the word to vector. Simple, there we are using back of word TF-IDF. I think you are already to learn about it. Word to vector. This kind of features engineering also applicable. Okay, to transform a word into a vector, this kind of features engineering are also applicable. Okay, this is also feature engineering. Okay, I think it is now clear All are you clear about it? What is feature engineering and how it is useful to separate a non-linear data to linear data? And it is not only useful in to separate non-linear data to linear data, it is useful in machine learning various aspect. Okay, just you can see step by step. Just you are seeing that we may assume some logistic regressions. We have assumed that it is almost linearly separable data or separable linearly, then only you can use the logistic regressions. But using the only features engineering, we can see how a non-linear data easily separated linearly, separated. And for a low latency requirement, logistic regressions also useful for low latency requirement system. And simply nonlinear data is by simply feature transformation using, we can easily build a low latency model by these features transformations. Okay, I think if you have any doubt, please comment below. Then I am always here to help you. Okay.